This video is going to be on box plots. The first thing that we're going to talk about is how to read box plots. And a lot of this stuff is still GCSE content, so there's only really one new thing for A-level. But I'm going to go over the stuff anyway. So the first thing that we need to know is that this point here is going to be your lowest value in your data. So say we have a data set. So our lowest value is going to be 1. So this value here will be 1. Then on the other side, this is going to be our maximum value. So the highest is going to be 10. Now these bits in the middle is what we're really interested in. So we have to know that this here is going to be the lower quartile. This here is going to be the upper quartile. And this in the middle is going to be the median. So we're going to know that this value here is going to be 3. This value here is going to be 9. And the median value is going to be 7. So that's really all we need to know about box plots in terms of GCSE content. But the new thing that we need to know is regarding this x. And this x here is what's called an outlier. And what an outlier is basically a value that's an extreme of the data. So imagine we have all of this data here, and that nicely groups into there, but then we have, say, 32. Obviously, 32, it doesn't really coincide with this data set, so we're going to say it's an outlier. So we're going to mark it outside of the box plot with an X to signify that it's an outlier. Now, typically in a question, the boundary for where an outlier is about 1.5 interquartile ranges from, well, in the quartile range. So our interquartile range, so IQR, is going to be equal to the upper quartile, take away the lower quartile. So we can see in this case, it's going to be 9 take away 3, which of course is equal to 6. So that means that if we have our lower quartile there, then the boundary for an outlier for our lower quartile, we're going to do 3 take away 1.5 multiplied by our inner quartile range, so 6, which is going to be -6. So if there's a value smaller than -6, then we're going to represent that with a dot, with an X as well. Now this is for our lower. Now for our upper, we're going to say the same thing, but it's going to be 9 plus 1.5 times 6 because we're going above it. See, in this case, it doesn't make sense to go above because this is the start of the where the quartiles are. So we're going to go backwards, and at the upper quartile, we're going to go forward. So this is why this is negative and this is going to be positive. So for our upper, we're going to do 9 plus 1.5 multiplied by 6, and that's going to be 18. So if there's a number that's either greater than 18 or less than -6, that means that we're going to represent it with an X, and it's going to be an outlier. So we can see that 32, it is greater than 18, therefore it is X because it's an outlier. Another thing to know about box plots is what they're representing. So each different section, so this section here, this section here, this section here, and this section here, these are all going to be 25% of the data. So this is going to be the first 25%, then the second 25%, then the third 25%, and the fourth 25%. So obviously 4 times 25 is going to be 100, so 100% of the data. So we can see that the data from the median to the upper quartile is going to be more spread out than the data from the lower quartile to the median, because we can see that it's wider, so that means that the data is more varied. And here the data is more together, so it's more squished together. In a question, you might get something that says outliers are going to be 2 sigma from the median, and that just means 2 standard deviations from the. So in order to work something like this out, first we need a few different things. So we need our n, and let's just say n equals 9. N can be anything, it just depends what you're given in the question. We're going to say sigma x is going to be equal to 92, and we're going to say that sigma x squared is going to be equal to 1428. So if we're being asked to find what values would be outliers, then we have to find what the standard deviation is first. So we can do that with the formula sigma, which is the symbol for standard deviation, is equal to sigma x squared over n, take away x bar squared. So what this is saying is that the standard deviation is equal to sigma x, so the sum of all of the x squared terms. So we're going to do this number divided by how many terms there are, which is 9, take away the mean. And we have to work out the mean for this, but the mean is just easy. The mean, which is denoted by x bar, is simply equal to sigma x divided by n. So x bar is the mean, so if you're to find the mean, you're going to add all of your things together and divide by how many there are. So that's basically what it's saying. Sigma means the sum of, and x is just the x values. So the sum of the x values divided by n, which is how many there are. So in this case, x bar is going to be sigma x, which is 92, divided by n, which is 9, which is equal to about 10.22. So now to find sigma, we've got our x bar, we've got our sigma x squared, and we've got our n. By the way, these letters are both sigma. This is the uppercase Greek letter sigma. This is the lowercase one. This is for standard deviation. This is a summation. But anyways, now that we've got all of our values that we need, we can write sigma standard deviation is equal to sigma x squared, which is 1428, divided by n, which is 9, take away x bar, which is 10.22, and square that. And if you put this into a calculator, we're going to get approximately 7.36. So therefore, any outliers are going to be 2 sigma, and we know that 2 times sigma is 2 times 7.36, so 27.36, which is going to be median 14.72 added to the median or taken away from the median. So we're going to know that any outliers are going to be 2 times sigma, which is 2 times 7.36, which is 14.72, added or taken away from the mean. So any outliers are going to be either less than 10.22 take away 14.72. So we know that if there's a value that's smaller than negative 4.5, it's going to be an outlier. And if there's a value that's greater than 29.94, then we know that that's also going to be an outlier. So we know the outlier is going to be either less than negative 4.5 or it's going to be greater than 24.94.